In the consumer healthcare market, the focus of product designers, once targeting the medical professionals, such as doctors, physicians, and nurses, now includes consumers and patients. Many consumers tend to favor products that have the most appealing design and are the most convenient to use, even if alternate products with the same capabilities are slightly cheaper. In order to beat the competition in the marketplace, it is no longer sufficient to design medical devices or packages that capture the functional needs of the end users. Beyond its functionality, a design must stand out with its appeal and ease of use. Prescription medication needs to be taken properly and on time to be effective. Patients often need help in maintaining medication compliance. A medication reminder provides this help by reminding the patient to take the right medication with the right dose at the right time. In this demonstration, I have created an innovative design that is appealing, functional, and very easy to use. To slide out the blister card, you only need to use your thumb. Rather than indicating a dependency on some medication technology, it has the look of an everyday accessory. However, I don't have confidence to proceed with this design. I don't know how it will behave in real-life conditions, or if it will meet the product specifications. Typically, a design goes through the process of prototyping and physical or virtual testing before going into production. But even if the testing is virtual, it is often so late in the design process that changes are difficult and expensive to make. If it turns out that the product does not behave as desired, I will need to come up with improvements. This process can lead to a number of iterations and lengthen product development time, resulting in many extra working hours and additional costs incurring from being late to market. DesignSight from Simulia makes it possible to virtually test a variety of ideas and options and helps me create a design that behaves according to specification and meets the consumer's expectations. Let's see how DesignSight can help me to gain confidence in my design's performance. A medication reminder is designed to fit into the back pocket. What if you have it in your back pocket and sit down? Is it sturdy enough to survive? Will it protect your medication? We are going to use DesignSight to simulate a 165-pound man sitting on a hard chair with the device in his back pocket. For this purpose, we are going to simulate 3 different designs with varying top covers, and we are going to pick the best design to withstand this loading condition. The best design should be the strongest to withstand the loading but still meet other criteria, like making sure it does not feel too flexible. To predict this, we will search for the design with the minimum stress values. In order to protect the medication and give it a high-quality feel, we need to make sure the top cover of the device does not come into contact with the medication. To ensure this, we will look for the design with the minimum displacements, which will be an indication of how much the parts have moved from their original positions. The medication reminder is an assembly consisting of 2 parts. We are beginning our simulation process using the initial design proposal. The top part of the base design for the medication reminder has a simple shape without any ribs or reinforcements. We are going to perform the structural simulation directly on the CATIA model created in the V6 environment. V6 PLM manages all aspects of design, from part design to product assembly and all the way through to simulation attributes and results. Defining a simulation in DesignSight is as easy as going through the actions outlined in the simulation panel. Once an action is checkmarked, I can go to the next one. The assembly and materials are checkmarked to start with. I had already defined them earlier, and there is no need to redefine them. When I am in doubt about an action or what to do next, I can always get information and tips from the DesignSight Assistant, which gives me context-sensitive advice based on what I am trying to do. Next, we want to make sure the 2 parts are structurally connected with each other so that they stay together during the simulation. Creating connections between parts is very easy. With a single mouse click, DesignSight will automatically create connections between parts that are in contact. I am going to review the connections created through the review panel. The highlighted regions show where the parts were bonded together. The region of the device that is trapped between the person's body and the hard chair can be modeled by interacting directly with the 3D model without accessing any menus or dialog boxes, making the whole experience very smooth. The last step before running the simulation will be to apply the body weight of the sitting person in the appropriate location and direction. Again, I can modify the direction and application point of the load easily by interacting directly with the 3D model. The status icon in the simulation panel indicates that now the simulation is ready to run. To obtain highly accurate and reliable simulation results, DesignSight uses adaptive finite element analysis technology. It takes just a few minutes for this analysis to complete on my laptop, but to get to the results more quickly, I also have the option to submit the simulation on a remote parallel computing cluster. Once the simulation is completed, I can easily review the results directly in the V6 environment. I will start by reviewing the stresses in the model. Looking at the legend, I can see the maximum and minimum values. To identify the most critical region in the design, I can locate the region with the maximum stress value. By selecting the play button, I can view an animation showing how the assembly deforms under the applied loading. Let's switch results and see values of how much the model has deformed. Based on the design requirements, I'm worried that the cover is too flexible, but with DesignSight we can quickly try out new ideas and evaluate other design options. Let's start with design number 2. I want to try reducing the stresses and displacements by increasing the stiffness of the top cover. For this purpose, I incorporated ribs on the inside of the part. I already set up the simulation models for this design and another, design number 3, and I am going to run these simulations directly from the search results. Once the results are ready, I can see that the maximum stresses in the model have increased. By taking a closer look at where the maximum stresses are occurring, I notice the stress concentrations on the ribs. The overall displacements didn't get reduced either. These results show that including ribs in a design does not necessarily always stiffen the parts. In my third design, to reduce the local stress concentrations at the ribs, I modified the ribs by introducing fillets and increasing their thicknesses. Now let's look at the results for design number 3. Stress values are significantly reduced and we do not see local stress concentration on the ribs anymore. The maximum displacement values are also less than what was observed in the other two designs. Finally, DesignSight makes it easy to summarize our findings and compare the simulation results for all 3 designs with each other. From left to right, I have the base design, the design with rib reinforcements, and the design with fillets on the ribs, as well as increased rib thicknesses. Design number 3 has the minimum stresses, which indicates it is the strongest to withstand the loading. The design with the minimum displacements will be the best to protect the medication inside. Again, design number 3 has the minimum displacements. By simulating several design options with DesignSight, we were able to quickly identify design number 3 as the best option early in the design process and without prototype testing. So, what are the benefits of DesignSight? First of all, it's easy. We saw that the user experience is self-explanatory and intuitive. Additionally, since DesignSight is part of the V6 PLM environment, I know that I'm always working on the correct version of my design. Then, it's fast. It took me less than an hour to do all of the design modifications and simulations you have seen in this demonstration. In addition, if I need to, I can reduce the solution time, already quick on a laptop, by using more powerful parallel computing resources, allowing me to try out even more ideas and still help bring the product to market on time. That way, I'm able to understand the real-life behavior of my product without waiting for someone else's feedback or waiting until it's much more difficult and expensive to make changes. And it's integrated. I can design and virtually test my design simultaneously, allowing me to introduce necessary improvements before passing it to someone else. So I am able to try out new ideas, leading to innovative designs. And because DesignSight uses proven Abacus FEA technology, not only am I confident in my product's performance, but so is the rest of my team. Finally, DesignSight is part of V6. This means I can manage all my simulation data securely, so I can search, retrieve, and reuse it whenever I need to, and share it with my team, suppliers, or management in collaborative decision-making. If you need further information about DesignSight, please visit us on the web or contact your local Simulia office.